From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 382, recorded live Thursday, July 25th, 2013. Support for Hansel Minutes is provided by Telerik, offering the best in developer tools and support. Online at telerik.com. And by Franklins.net, makers of GesturePak, a powerful gesture recording and recognition system for Microsoft Connect for Windows developers. Details at gesturepak.com. In this episode, Scott talks with Chris Walker about how SecretLabs created the Agent smartwatch.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. You can hear our ambient noise here. We're in a hotel in Chicago. We've got Chris Walker from SecretLabs. How's it going?
Yeah, good. Good morning, Scott.
We're going to go and give a presentation in a little bit on, being able to do .NET on your wrist. This is amazing. You guys just came off of an incredibly successful Kickstarter. You raised $1 million.
Yeah, it was pretty amazing. We're pretty excited.
Did you think you were going to raise that much?
You know, we had this vision for what a smartwatch could be and should be. Part of that based on what .NET did 10 years ago with the spot watches, and part of that based on what we believe they can do in the future. And we were just really excited that so many people shared that vision and got excited about it.
And did you think it was going to hit $1 million? Like, I know that you had like an emotional connection to the $1 million. You were texting me at like 950,000.
Yeah, so I think it's for our community more than us. You know, for us, we were happy to hit the $100,000 goal because that meant we could put this into production and see this baby come to life. But yeah, for our backers, there's an emotional connection with having backed a project that hits $1 million. Mm-hmm. There's only 36 in the history of Kickstarter.
Really?
And so, yeah, being able to be involved with a project that hits that number it really means a lot to the people who back the project. And for us, it's great because it's enabled us to get a lot of phone calls from retailers and partners and everyone else who want to be involved with .NET on the wrist.
Mm-hmm. Now, Kickstarter goes out of their way to make sure that people understand that they're not a store.
Yeah.
And they're really pushing this idea. And I've backed a lot of Kickstarters, and I've had some successful, some not.
Yep.
There's been trouble with some Kickstarters where people aren't feeling like they get charged, and then a year later their product
or
shows
two,
up.
yeah.
Right, or 2 or 3, right? Also, you hear in the comments on Kickstarter people saying like, well, you're getting a whole pile of money. Isn't it true that Kickstarter isn't a big profit thing for you? Like, you're not necessarily going to clear $1 million.
Oh, no.
Because it's a proof of concept, right? It proves that people want the watch. It's not like you're going to clear $900,000 and then go and bang out a couple of watches for $100,000.
Yeah. So the reality of the situation is that there was a lot of investment that went into building something like the Agent smartwatch before we even started. You know, for us, the $100,000 of Kickstarter funds that we were asking for helped us be able to do the FCC certifications and a couple of things. But even at $1 million, you know, after we build all the watches and we put all the extras that we've decided to put into the watches to make them better for everyone, the profit comes from pre-orders. It comes from the orders afterwards. You know, we're excited to be able to make it, and that's what Kickstarter enabled. But if you look, you know, a lot of projects are trying to sell prototypes as finished goods, and those are all moving to Indiegogo now because Kickstarter is so big on making sure that people realize that you're putting money into making something happen. You're not buying something. That a lot of projects that would have been on Kickstarter in the past in the hardware category are simply not qualified to be there anymore.
So you guys had experience in this space from NetDuino.
Oh, yeah.
And I was a fan. Pete Brown's a fan. We've been talking about NetDuino for forever. You know, I've supported you guys from the beginning. What made you decide to switch to the watch? Like, were you just sitting around and you just said it was time? You
know, we've been wanting to do, well, personally, I'm a big fan of high-tech watches. I've had, you know, the Casio DataBank and the Timex DataLink watches in like the 80s and the 90s. I've always loved high-tech watches, the fashion ones, the tech ones. We want to do this, but it's just so expensive to get something like this off the ground. And about 2 years ago, I was talking to Mark DeVink from Make Magazine. He ran Makershed back at the time, or was heavily involved there, product curator. And we were talking, and he wanted to make a watch, and I wanted to make a watch. And we said, well, let's do this thing. And we started doing that together. And then since then, Makes got spun off as a separate company and everything else. And we decided we still wanted to do it. So we just made it happen. Mm-hmm. But we couldn't completely make it happen without our Kickstarter backers, right? We could do the proof of concept. We could build the prototypes. We could make the platform work. But it costs a lot of money to bring something like this to market.
Mm-hmm. Talk a little bit about NetDuino. and then let's kind of work our way up to the guts of the watch. 'Cause,
Yeah.
like, I'm looking at the Netduino 2 Plus here. You
Yep.
know, and it's the size of my palm.
Yeah, it's a little bigger than a credit card.
Right, there you go. A deck of cards, almost a little
Yep.
smaller, but it's got a micro USB, and it's got a Ethernet, and it's got the GPIO ports. You know, it's tiny. It's a miracle of science. It's even got a little mini. This is a micro
SD card.
Micro
Yep.
SD card. What are the capabilities of this device?
So what Netduino is designed to do is it's designed to make it so that software developers can not only make apps for the web and apps for their phone, but they can also make apps for electronics. They can actually build their own custom electronics. You know, when I was young, being into software was a unique thing. There weren't a lot of software engineers out there. And so it wasn't a very crowded market, but now it's like anyone can make an app for a phone, which is a fantastic thing, but it also means that there are very few new exciting places you can go with skills unless you're inventing a new category of something. Well, we made the transition to electronics, and we wanted to help enable other .NET developers to do the same thing. So with a Netduino, you can build an irrigation system for your home, or you can build a radiation detecting system that sits out on the sea and relays data back via the satellites. You can build Halloween costumes. You can build just kind of anything that has motors and LEDs and switches and relays and all these kind of things using .NET.
And this is an ARM processor.
It is. It's actually the new Cortex M4F. So it's kind of the latest and greatest in the embedded tiny microcontroller world.
And what is the powers of this ARM processor versus the ones that we hear about in things like a Surface or a phone or things like that?
So it's the same kind of core ARM technology, but this processor is 168 megahertz versus like the one in your Surface, which is going to be, let's say, over 1,000 megahertz. The big difference really, though, is those are microprocessors, and the one on the Netduino is a microcontroller. Now, fundamentally, what that basically means is an entire kind of computer on a chip, the flash storage, the memory, all that sitting inside the microcontroller. And then it also has the capability to do things like raise and lower voltage, to encode a digital wave to be able to move motors, things like this, to read voltages, to measure things. These are not things you find in like the processor on your Surface, but you do find in the microcontroller that's on an Netduino.
So the Netduino and embedded systems like this are kind of a controller in a model view controller world. It is not about raw processor power as it is about interacting with the world.
Yeah, it's about command and control. You know, you do have a lot of rich capabilities with .NET on this microcontroller to be able to write code the way you normally would. You're not having to worry, traditional C programmers who build things, even people who build things on like Arduinos and raw AVR microcontrollers, they're stuck in this world of a loop. You set up kind of everything, and then you have a loop where you keep on checking conditions, and you have a state machine.
Right.
And you run through it over and over and over again.
Yeah, it's like video game programming. It's like, while true, right? Okay, move the little guy, check for input, and then do it again.
Yeah, but in the world of .NET, you can say, create a thread and have it do this. I want to have a auto reset event when it gets triggered. Go ahead and let this code run. I want to have mutexes, and I want to have semaphores, and all these things that you've got in .NET. So many of them now you can program with that same style on a microcontroller. You can even share your code.
So I can have event, like there's a button here.
Yep.
I can have a button click event.
Yep. Yeah, button was pressed. You get an event in your code. If a light sensor gets above a certain level, you can have a class that's continuously checking that level, and it raises an event. If you had a GPS receiver hooked up, these things have serial ports in them to talk via NMEA to those. You can kind of live in this event-driven world just like you would with a desktop or phone application.
But now that layer of abstraction reminds me a little bit of web forms, the way that web forms hid HTTP and put events on top of a stateless world. And some people thought that was amazing, and it enabled a whole new generation to program the web. But aren't you making embedded systems development too easy? Like, couldn't hardcore people be like, this is not cool. This is web forms for embedded systems.
There are some people who would rather twiddle bits and registers at a low level. Actually, that brings up one of the advantages of the .NET Micro Framework, in that it's the version of .NET by Microsoft, which is open source. And so we actively encourage people, if they want to work at that low level, they can actually modify the source to .NET Micro framework, and they can create their own capabilities. They can twiddle the registers in their own code.
Do they, though? Because you know how we always say, you can always use... you can always just fork that. Are there companies that are making their own forks?
There are companies. In fact, it's interesting because with Netduino, we end up in a world where we don't know what most people are doing with Netduino. We sell through Mauser, so we got the big electronics distributors. We sell through Amazon.com and Radio Shack, so we've got the places that people pick these up on more of a hobby side. But when you're making 250 of something as a company, you just stick the Netduino inside your box. When you're making tens of thousands of something, you take our open source design files and you create your own circuit boards and you derive from our firmware source and you add your own features in. The funny thing to us is we only find out about these things when they're shipping in the field and we happen to open one up or we're talking to someone who built it.
Seriously.
And they let us know.
You discover that someone's doing this because you open up some fire extinguisher or whatever, like, oh my goodness, there's a Netduino inside this thing.
Usually it's like an engineer who lets us know, oh yeah, we use Netduinos when we prototype this and we derived from that to build our product.
So I can see this as a prototype board. When it's time to go to market then what do they do?
So if you're just making a couple hundred of something, embedding a Netduino inside your product and just building an expansion board for it with your sensors or whatever you have, makes a lot of sense. When you're making thousands or tens of thousands, you can take the design files for the Netduino, download them off our website, pull them into your favorite PADS compliant design software, into Allegro, and you make it into your own board. You order the parts, you assemble them, you do all those things that no one wants to do unless they're building a ton of units.
So I'm not even going to try to parse out the last 15 acronyms that you've used, like Allegro and PADS compliant. But what I'm hearing you say is that the hardware itself is open source, right?
And the software. Netduino is 100% open source. Everything that we put into it, we give out the source code to, and we license that under Apache and Creative Commons.
So if I'm technical enough, I can take the board design and say, oh yeah, I totally see what he's doing here.
Yeah, you could even take our board design, send it to a manufacturer in China, take off the Netduino logo, and say, make me 1,000 of these for my X project. And they would know what to order and how to build it.
Okay. So then the Netduino, is it called the Mini?
We do have a Mini, yeah.
So the Mini, and this is where I'm trying to kind of work our way towards the watch. The Netduino is about the size of a deck of cards, a little bit smaller. The Netduino Mini is, the size of half of my pinky finger. It's really small.
0.72 square inches.
That's small.
Yeah.
That is a whole Netduino, right, on a tinier pad. I don't know what the language...
A little circuit board, yeah.
Little circuit board here. And that is the guts of the watch?
So that was the guts of the prototype watch. And again, the Netduino Mini is kind of a scaled down Netduino. It doesn't have USB. It doesn't have a power plug or anything.
Obvious stuff that it can't have because it's too little.
There's no room for that. Yeah, so when we first prototyped the watches, this is an interesting story. We actually designed what would be the production circuitry for the watch. But when you go somewhere like Kickstarter and you're sharing your vision with people, you really want to have a product that you can show them as far as a prototype. So we originally prototyped the watch not on Netduino Mini and not on our custom circuitry, but on the regular Netduino and Netduino Plus. So we had wires hanging out of them and everything else. So we actually took a step kind of backwards when we built our prototypes because we'd already prototyped with wires and then we had designed our production circuitry. But to put something inside of a watch form factor so that we could share it with people and show them our vision, we took the Netduino Mini, which runs the same technology. It's a product we created from our Netduino line, and we put it inside of a watch case on a custom circuit board with all the parts.
Interesting.
So the prototypes you see are true prototypes, but they're also ones we actually created that we normally wouldn't have created had we just done the product in-house because they're a step we didn't need to take. But it is a really easy way to share with people how the technology works. And the code that's running on that prototype also runs on the production watches because .NET is effectively a virtual machine for code.
So trying to visualize this, maybe there's pictures you could show me sometime. Is there a picture of a breadboard with a Netduino on it and wires hanging all over? And you say, look, there's the prototype watch.
Lots of wires.
It takes up a whole table, and it's don't touch it or it won't work.
Yeah, in fact, it's not soldered together, so please don't pull any wires out. Yeah, that's how we started. We actually built little breakouts for the display that took all these little tiny wires that are in this thin cable on the display and put them into pins that were spaced 0.1 inches apart. We stuck that in a breadboard. We wired it up to an Arduino Plus. We plugged in sensors and pull-up resistors and all these things that if you play with Arduinos, you come to know and love. And that's how we prototyped the watches in the first place. All using .NET Micro Framework, all using SecretLabs Arduino products.
So just like you described, then the next step would be to go and design the production internals of the watch, but instead you had a halfway point where you could go and hand an investor or an interested party a smaller prototype.
Yeah.
That's still a prototype.
Using the same technology that we built our original prototypes on. But yeah, funny enough, we actually built that prototype after we had already designed our production circuitry.
And I'm running actual C# and an actual tiny CLR.
Yep. On the board, and your code is living on the board. So it doesn't have to be plugged into a computer for your code to run. It simply runs in the chip on the board.
And this is the same micro framework that that enabled the original kind of smart personal objects technology.
So kind of. Okay. So Windows 8 is the same Windows NT 351 that shipped in 1990.
Gotcha.
What was it? 95? The
so
Spot
it
framework
shares the heritage.
Yeah. It shares the heritage. A lot of the original code base is even sticking around. You'll see that when you use your drawing primitives to draw on the screen of the watch, you're using classes that say Spot in them. Because we took the best of what existed 10 years ago in the Spot watches with the best of what exists in .NET Micro Framework today.
Okay.
But it's 10 years newer in version 4.3 instead of version 0.beta. It's a radically different world.
So it's totally reliable. It's totally something I can count on.
It's been proven on millions of devices in the field. Yeah, okay. And actually in the watch, we took reliability to another level because we're doing things like dual recovery mode bootloaders. We have watchdogs. We have 2 microcontrollers, one of which can override the other. There's a lot of technology.
And this matters why? Because I don't want to brick my watch?
Yeah, a watch should be an amazing timepiece that just always works. You don't want to start thinking a watch as a computer. And because it's completely wireless, it has wireless charging and it has wireless for Bluetooth for communication. You never want to get in a state where you start flashing an update to it, your phone dies, and all of a sudden you've bricked your watch. We wanted to make sure that fundamentally you couldn't brick your watch.
That's scary.
Even with custom apps.
Isn't that scary as a designer? The idea that you're creating something and at some point you have to put it inside the case and then call it water resistant.
Well,
and then
let me add one more to that. And then you enable millions of software developers who know C# to write apps for it. And you have to make sure that you protect it in a way so that they can play around and they don't have to worry about damaging their or other people's watches. I hear a lot of people, they're like, oh, I'm so glad there's an emulator for the watch so I don't have to worry about hurting my watch. And I just kind of smile and I'm like, I'm really glad there's an emulator so you can get started on code right away. But you don't have to worry about breaking your watch.
Because some watches that are out there that are smart watches can be bricked.
Well, it's a whole different ballgame. Yeah, in fact, I was looking at a high-tech watch the other day. We'll call it a smartwatch for this conversation. And they had a disclaimer on there that said, download the source code, review it yourself, compile it yourself before putting anything on this watch, because it's very possible to brick this watch. In fact, some of the smartwatches have issued firmware updates that if you turned your watch off to save power after updating the firmware, you had to send it back to the factory to get them to load the new firmware that wouldn't do that anymore.
Wow.
These things are built with the lowest cost materials, the lowest cost methodologies. When we built Agent, we wanted to build something that was really premium, well thought through, and set a new stage for what a smartwatch could be.
And certainly we're not trying to be, I'm hearing in your tone, you're not trying to be mean or punitive towards
not at all.
Towards other smartwatches.
I love what other people are doing. I just wish that we could take things to a new level.
But it does appear that there's a fundamentally different philosophy in that you have chosen to build on top of this framework that runs at a different layer of abstraction. Yep. I mean, there are little garbage collectors, and there is, it's a different way of thinking about running code on an embedded device.
Inside of a protected virtual machine that makes code safe.
And I can use an Express version of Visual Studio, a free version of Visual Studio, to write code for my own watch.
Yeah, the demos you'll see me do, I use Visual Studio 2012 Express for Windows Desktop.
Don't you think that it is that lack of openness that's why the original Spot watch failed?
I think the original Spot watch, which is still one of the most advanced smartwatches ever made, I think I had three things going against it. One was the $60 a year service plan to be able to get data on your watch. It was before we had the pervasive internet connections always flowing through to our cell phones and this connection to the cloud. So that really hurt it because people love the watches, but they didn't want another service plan for a watch or, three because they had members of their family with watches. But the SDK, like you mentioned, there was no SDK. You couldn't write apps for the thing.
There's no app store.
It's just a cool watch.
There's no watch app store.
Yeah.
Right.
Or capability to write your own apps.
Yeah. Yeah. We would always get excited, like, oh, the weather app is coming, or the new.
Yeah.
Just like, give us an app.
But these apps were delivered over the subcarrier FM radio signal that's like 2400 and 9600 baud shared amongst everyone in your town. So there really was no way to sideload apps. There was no way to load custom apps because there just wasn't the bandwidth for it.
Well, and Bluetooth wasn't there, and you're basing your stuff on Bluetooth 4, right?
So we have Bluetooth 4.0 BD-EDR plus LE. What that means is that we support...
You're going to have to slow down.
Yeah, I said that fast because it wasn't going to be understood no matter how slow I said it. Bluetooth 4 is a very nebulous thing because a lot of people think Bluetooth 4 means the new low-energy Bluetooth, and a lot of people think it's just the newest version of Bluetooth, which is what it is. We support both classic Bluetooth, which is what Bluetooth 3.0 was and 2.1, but we also support the no low energy mode, which lets you talk to things like the iPhone 4S from your watch, and also makes it so that instead of connection that you start and then it takes a lot of power while you're setting things and then you disconnect and it's awesome. We're using low energy, which can wake up, transmit tiny bits of information and fall asleep very quickly, which really helps on battery life.
Because I've heard that with Bluetooth low energy, that the theory is that devices could last a year.
Or two, on a coin cell battery. For a watch, we're living in a world where we have a microcontroller and a screen and everything else. So, we're shooting for a week, not a year.
Well, a week is certainly reasonable. I have smartwatches that I charge every day or every other day.
Yeah, in fact, it's a problem for us that it lasts so long in a charge because people understand charging every day. They have no metric for, I charge, is it Friday night or Tuesday night? Like, there's no rhythmic cycle like you have with just plug it in every night. So one of the things we did, which is a really novel thing with Agent, is that we gave it a Coulomb counter, which is in effect a gas gauge for your watch.
What is a Coulomb?
So it's measurement of how much current is flowing through a device. So you can measure how much power you're using out of the battery. With your smartphone, it has one inside so that it knows what state your battery is at and how fast you're eating power. There's a lot of tools. Like if you saw the demo at Build, the Visual Studio 2013 with Windows Phone, it can show you how much battery you're networking and different features on your app are using, which is really useful because you can profile your app to be energy efficient. And we could live in a world where smartphones start lasting for days instead of, a day. Well, with the watch, our battery is 10 times smaller than your smartphone, but we have to last like 10 times longer. So we live in a world where we really have to understand how much power we're using. This is why we put that tech in there. So app developers can profile apps and give you amazing battery life with powerful apps. It also lets you know how much battery is left so that you understand, okay, in a couple days, I should throw this on the charger.
See, that's really interesting that you bring up a point that the expectation is that I want, like the Dick Tracy watch phone, right? And I want to see like a full color image of Dick Tracy and I want to be on the phone and I want it to last for a week or a month. Like you said, it's 10 times smaller and we want it to last.
I want it all and I want it now.
It's totally unrealistic, the expectations.
Well, we're getting there and we're pushing those boundaries. With Agent, we're really trying to help move the industry forward. And I think that eventually the color displays will happen. There's actually some new tech there, which we've been looking at and playing with, but it's just not the kind of quality you want on a watch today.
We'll talk about the display a little bit. Everyone keeps saying e-ink, but instead we're ending up using these low power.
So they're memory displays. They're actually memory LCDs. And what it is if you took a LCD display that was 1 bit, so monochrome, and you scaled it way down in power, and you actually embedded a bit of memory behind every pixel physically in the display, you'd end up with a display that takes about as much power on average as like an e-ink display, except it's fully animatable. So you get 15, 30 frames a second on it. So you get these really smooth, rich user interfaces. Whereas with a technology like e-ink, or other types of e-paper displays, you end up in a world where it refreshes like, you could actually see the screen like reverse and flip like it does on your Kindle. We wanted something that was the quality of an LCD display on a traditional watch, but super high resolution. We're 141 DPIs, which for a watch is pretty fantastic.
And does this use power? Like, forgive my ignorance, but that's my job to be ignorant. Does this use power to keep it on?
It does use power to keep it on, but we don't have to keep our processor awake to keep on sending it the display. So we don't have to 60 or 30 times a second say, here's your display, here's your display, here's your display, here's what you should be showing. We simply update it when we want to, and then we just give it a tiny bit of power and an occasional pulse, and it keeps that display going. It's ridiculously low power.
So if I let's say that I have my watch and I am using it only as a watch, and it has some basic screen that is only updating the seconds.
Yep.
Is it asleep for 9/10 of a second?
It's asleep for like 99 hundredths plus of a second. Yeah. Yeah. So the entire framework, and this is one big advantage we have with .NET Microframework as well, is everything is built to be asleep unless it's running code, which means whenever you're not doing something, whenever there's not a thread running, whenever there's not a timer going off, the processor goes in this super deep sleep mode where it uses almost no power.
It's interesting that you say that, because when I first started playing with your emulator, which is really nice because I don't have this watch,
right? But
I have the emulator.
Well, you'll get yours.
I get my. I'm looking forward to my watch. But this is great because you have an emulator and it looks just like the watch and it's got buttons like the watch.
Yep.
And I was writing this code on learning how this watch works. And I noticed that you set up kind of these event handlers, these kind of lambdas, and then it just exits.
Yep.
And I was like, hang on a second. And I think I remember either emailed you or called you. And I was like, well, where's the while true?
Right. You don't want to do a while true. That'll just eat your battery by sitting there spinning forever.
So help me understand. You write this main and you set up a bunch of, interrupts and expectations.
Yeah, an event that every second or every minute it's going to call your code to refresh the display so that you can show the second hand moving, or you can update the minute on your display, for instance.
How does the process not exit? Like, what is it that makes the process exit?
Well, so for your process to exit, if you didn't have any threads running, if your main routine doesn't go to sleep, your code would just run, your process would exit. It's the same as writing a console application on the desktop. If you wrote a console application and you did 5 things and then you just run to the end of the main event, your program stops.
Right.
But if you call a couple threads in the background and then you say system threading thread sleep infinite, it's just going to keep on running forever and those threads will run in the background. It's .NET. It's the same kind of .NET as you'd use on the desktop.
Really?
That's our model. And what's cool is internally inside of the IL interpreter, it checks constantly it runs your code and then it's always checking after instructions, am I done? And if it's done, and there's a thread that's going to get called later based off an interrupt, or there's an event, it actually sets that up and says, okay, I'm going to sleep. When X happens, I'm going to wake back up. And you don't know that that's going on in your code. All you know is you just use event-based programming techniques you've been using for years. You can have multiple threads. You have timers that go off. But literally, when your app is not doing anything, that processor is doing everything it can to be in the deepest sleep mode possible.
So how am I going to connect this? There's no USB plug, right?
Right. It's completely water resistant, and there are no wires going into it.
So how am I going to write my glucose meter?
So here's what's cool about that Bluetooth. So we've got both Bluetooth Classic and the new Bluetooth Low Energy inside the device. So from Visual Studio, you simply set up a Bluetooth serial port in your Bluetooth settings on Windows that's between your watch and your computer, and then you deploy. You hit that play button just like you would to run any other app, and it deploys it, and you debug in real time. You can set breakpoints. You can run to command. You can hover over variables. They'll tell you what they are. It's just like using a Windows Phone 8 device, or if you've used Surface RT, for instance, you can deploy code and use a remote debugger on Surface RT. It's the same thing. You're just doing it on a watch.
So the same infrastructure,
wireless.
the same remote debugging infrastructure.
To you, it is. Behind the scenes is different, but it is the same to the developer.
And do I go into the watch's settings and say, all right, we're in debug mode now?
Yeah, so we're actually trying to figure out the best way to do this for developers. Right now, every watch is set up as a developer watch, but we're actually thinking we might ship them all as kind of non-developer watches, and then we'll let developers reflash, because you can reflash without having to worry about brick your watch. They'll actually be able to reflash their watch in developer mode, and then it will let them deploy that code. Now, any watch, whether it's in developer mode or not, you'll be able to not only use the App Store to load code, but you'll also be able to deploy code from a side-loading mechanism or through a Windows Phone app. We've created this as an open ecosystem so that you're not tied to any specific app or process to get apps onto the watch.
Okay, so that was my next question. I will I want to write a glucose meter.
Yep.
And figure out how to have it talk to my blood sugar meter. But I also want to be able to download whoever, like I know Rafael Rivera and Long Zheng and those guys are going to go and write some amazing apps.
Yep.
I want to just download them off of their website.
Yep.
Then acknowledge the something bad will happen acknowledgement button.
So the watch itself, your apps are sandbox. So there's very few things that will tell you shouldn't run on your watch. The main time that you'll get a flag telling you that maybe you shouldn't install something is when we know that it's going to consume vast amounts of battery power and doesn't fit into our battery power guidelines. Best practices for having apps that last a long time. Yeah, you can just go ahead and do that. In fact, if you want to, we'll even let you write code inside of your Windows Phone or your Android app to load an app directly onto the watch without using our loader app.
So that's another great question, is that let's remove the computer from the equation.
Yep.
Now I have a phone.
Yep.
I have an iPhone. You have a Windows Phone. There's also an Android on the table over there. How do I make my Windows Phone or my iPhone talk to the watch, and what kind of things can it do? So
that's also via Bluetooth. One of the nice things about the watch is that we can either pair to a PC, you can talk to your phone, you can talk to devices. It has a really rich Bluetooth capability. But we're going to be shipping a companion app for Windows Phone, Android, and iPhone. Some of that code, actually, we're using Xamarin Studio and the Xamarin tools to be able to use one code base that ensures that we can provide the same kind of capabilities to Android developers and iPhone or Android users and iPhone users as Windows Phone users, for instance. But you'll actually be able to download apps from the web and install them to your watch through your smartphone. You don't need to use a PC to use this watch.
That's pretty sweet.
To develop for the watch, you need a PC.
Yeah, sure. So this could become a companion device for all sorts of things. Like if I had a blood sugar meter on the phone, it could be running in a background process on the phone using the process power of the phone. Talking to the internet.
Yeah, so you can do analytics, use your phone as a gateway to transmit information, whatever the App Store policies of your particular brand of phone allow you to do. We have no policies. You can do whatever you want on the watch, right? But as long as it's on the phone, you can transmit that data to the internet, you can talk to those sensors, you're set. Very cool. So where can people go and pre-order this and get an emulator? So the Kickstarter campaign's over, but if you go to agentwatches.com, you can reserve a watch today. We'll have pre-orders later in the year, so you'll get to the front of the line for that. And then you can also download the emulator and the SDK directly off that website, agentwatches.com. All right. Very cool. Agentwatches.com. Thanks so much, Chris, for talking to me today. Thank you, Scott. This has been another episode of Hansel Minutes. We'll see you again next week.